Hello friends, let us see another previous year gate question. Now, if you see here, by seeing this question, I think most of us will leave the question as, isn't it right? So, but in examination point of view, what I am saying, see the first two factors. If you can able to find first two, then you can choose the correct option, isn't it? Even though you don't know remaining three, if you can able to pick the first two answers, then you will get the 2 marks question. It is a 2 marks question, so easily you can get the 2 marks. So in exam, if you can find two, more than enough. But while practice, you should know all these five how we have to find out. So for that, let us see the question. An embankment is to be made of a soil which has the following shear strength properties. Okay. So what are the properties? I'm drawing it on a new page. C dash that will be equal to 30 kilonewton per meter square, and phi dash that will be equal to 15 degrees, isn't it? Now, what they're asking, if it is assumed that different margins of safety are available for cohesion component and friction component of shear strength. Okay. Mobilized values are given. Cm is equal to 22, phi m equal to 12. What does it mean? Even though the soil is having 30 kilonewton per meter square, we don't utilize it completely. Why? Because if we utilize completely, then there may be some unexpected scenarios arise. Then there may be a chance that your soil will be failure. So that's why we will use some factor of safety. That means instead of using this complete amount, what we'll do, we will, with some factor of safety, we will decrease that to some mobilized values. That means we will check it only up to Cm is 22, phi m is equal to 12. So let me draw. So what are the mobilized values? Cm will be equal to 22 kilonewton per meter square, and phi m that will be equal to 12 degrees. So what they are asking in the first A, what they are asking, factor of safety with respect to cohesion and factor of safety with respect to friction. What is the factor of safety with respect to cohesion? That will be equal to strength of the soil divided by mobilized value. That will be equal to 30 divided by 22. So if you solve this, you will get this value as around 1.36. Even if you see the options, 1.36A, only one option is there. So without calculating anything, directly you can choose the option A. See, the problem is very lengthy, but if you do C dash divided by Cm, okay, easily you are getting 2 marks. So don't get frightened by seeing the length of the question. If the more length of the question, if you understand the logic, the easier the solution will be. Similarly, what is the factor of safety with respect to cohesion? Friction. That will be nothing but a tan phi divided by tan phi m. That will be equal to tan 15 degrees divided by tan 12 degrees. Then if you solve this, you will get it around 1.26. Okay. First one is 1.36, second one is 1.26. So after that, what we have to find? If the average value of the normal effective stress on the failure surface is 120, what is the value of true factor of safety? How to find the true factor of safety? F will be equal to shear strength divided by shear stress, isn't it? So this shear stress is based on the mobilized condition. That means what is the shear strength that you can written as C dash plus divided by sigma n into tan phi dash. If you're using the shear stress, that means mobilized condition. Mobilized friction plus sigma n into tan phi n. So if you substitute the values, you will get the values as 1.31. Okay. 1.36 done, 1.26 done, 1.31 is also done. Then what about the last option? We have to find factor of safety with respect to friction when Fc is equal to 1. So what they are giving? We have to find out F phi is equal to how much when factor of safety is equal to 1. So whatever we have written, so if I separate that equation, you know what I will get? So what we will write, F will be equal to, I will write it as divided by tau. That implies I can write tau, that will be equal to S divided by factor of safety. What is the S? C plus divided by sigma n tan phi. Then I will separate this factor with respect to both cohesion and friction. So mobilized shear stress, that will be equal to, as I am using C here, factor of safety with respect to C plus sigma n into tan phi into factor of safety with respect to cohesion. So this is what the equation. So in the fourth one, what we have to find? If Fc equal to 1, what is the F5? What is the tau m? That is nothing but a tau m. So here let me write down. Tau m is nothing but a already mobilized value. Cm plus sigma m into sigma n into tan phi m. If you solve this, you will get this around 47.5. So here 47.5, that will be equal to CV dash value. C dash value that is given as 30. Factor of safety with respect to cohesion 1. Normal stress is given 120. Tan phi dash is how much? 15 divided by F5. If you solve this, you will get factor of safety with respect to cohesion as 1.84. Similarly, what is the fifth one? In the fifth one, you have to find out what is the factor of safety with respect to cohesion. When your factor of safety with respect to cohesion equal to 1. Similarly, do this 47.5, that will be equal to 30. This is what we have to find out, plus 120 into tan 15 divided by how much? 1. That implies you will get factor of safety with respect to cohesion, that will be equal to 1.95. See, always see, you know this equation, and you have to understand that you have to write in tau, you have to take it in left side, F you have to take it in downward side. After this, you have to write down this. After this, should be able to separate the factor of safeties. So if it is a single parameter, okay, no problem. But if they are given separately, you have to separate factor of safety with respect to cohesion and also factor of safety with respect to friction. Okay. So here they are asking in combined way, in general, what is the factor of safety? But here, what is the factor of safety with respect to cohesion? What is the factor of safety with respect to friction? Thank you.